Hi, everyone. Welcome to Riot's Lunch and Learn series. My name is Caroline Griffin. I am Riot's Director of Operations, and I am so excited to have you here with us today for an awesome joint lunch and learn with our partners Air Electronics and Murata. We have Tim Cutler here to give us all the down low on wireless options for IoT. Before Tim gets us started, just a couple of quick reminders. If you have any questions throughout the presentation, please do put those in the chat box. Tim has agreed to answer all of your questions at the end of the presentation. This event is being recorded and will be posted to Riot's YouTube channel, and you will be able to find it on the meetup group where you registered for this event. Again, my name is Caroline Griffin. I just want to thank you for being here. But without further ado, I'll hand it over to Tim, our host for today's Lunch and Learn session. Thanks, Tim.
Thanks, everyone, and appreciate your time today. So IoT obviously is a very broad topic, a lot of interest, covering a lot of different products and products types. And so you also have a lot of wireless options. And one of the keys is trying to determine from all these wireless options which one's right and then how to get to market quickly. And so the products and services that Murata and Arrow offer, provide that way to get your wireless product to market quickly. And that's what we'll kind of look at today. So we'll look at the kind of the IoT technologies, just do a kind of a brief comparison, and then we'll look at some of the module solutions of the various different types. So we have Wi-Fi, Bluetooth combo parts. We've got the cellular, the LTE, Cat M1, NB. We've got Lora, and then the Bluetooth and BLe as well. But it needs more than just a module to help you complete your design and get your product to market quickly. So we're going to look at kind of the evaluation platforms that are available, so you get an idea of, you know, the work that's been done to simplify your evaluation and actually your design. And then we'll look at the support that is available to assist you throughout your design and development effort. And then at the end, as Carolyn said, we'll have some time for some questions and answers. So to get started, this is kind of a, not a lot of startling information here, but looking at Wi-Fi, Bluetooth, the Cat M1, NB1, and LoRa technologies, something that is really important, certainly over the last several years, is security, and that's why it's kind of at the top. Um, Everybody's concerned about having their devices hacked, and we've seen some pretty scary, uh, examples of where children have been, terrified by someone talking to them through their camera or speaker devices. So when we look at security, Wi-Fi kind of being inherently um, IP based, provides kind of in-device to cloud options, kind of built in terms of kind of the TLS and the WPA3s and the enterprise securities. Bluetooth really is more of a device-device technology, but you can still get that security if you go through some type of a gateway, and oftentimes that can be a smartphone, right? So you'll have that type of connectivity. Uh, Cat M1 takes advantage of the LTE cellular networks. So obviously the carriers have a lot of money invested, and so there's a lot of security um, in the cellular network. And then for LoRa, you have that technology has network servers so that it does provide security. It's kind of a two-layer thing where you have network security, but then you also have application layer security. So only the end device can actually decode the payload data. So the good news is that security has been recognized, and all of these devices have implemented very strong security. Not that you can't, you can ignore it, but it's really there and available for you. The other thing with IoT is power consumption is often a very critical consideration. And so there are two pieces of the power consumption. One is the peak or the instantaneous current, and that's typically going to happen when the transmitter is operating. And then you have the average current. So the peak is going to kind of define which battery chemistry or battery size is capable of powering the device. And then the average is going to tell you, okay, so how big a battery do I need to get a specific runtime? So Wi-Fi is in the peaks of 300 milliamps. Bluetooth really is kind of the low power leader here. 40 milliamps is certainly kind of the max there, and there are options that have lower peak powers. And then CATM1 and NB, the cellular technologies, can go up to about a half an amp when you transmit. So they have a lot of neat features to take advantage of the of the infrastructure, but there is kind of a power that goes along with it. And then Lora can be down in the low 100 milliamp type of range. So if you look at this, Bluetooth clearly can be powered off button cell type batteries. Lora could, kind of depending on the button cell technology has improved, but 100 milliamps is kind of getting to the peak of of that. And then the Wi-Fi and CATM1, you're really not going to be able to use that type of battery. Range is the other thing that's important. So Wi-Fi, you get tens of meters. You can get better, but we also know that in our own home, sometimes trying to go 15, 20 meters, can be a challenge. Bluetooth can get up to 100 meters. Now, the thing you have to keep in mind here is to get to the 100 meters, we're really talking more of some of the BLE technologies or the classic Bluetooth with lower data rates, and to get that type of power. The Bluetooth and SIG and Bluetooth 5 is increase the maximum transmit power that they'll allow, so you can get further than that, but then your current consumption goes up. CATM1 and Lora have very long ranges, about 10,000 meters for CATM1. That's really going to be kind of when you're in the highway and you've got a kind of a straight shot. The cell towers have some pretty high gain antennas to extend that range. If you're in downtown in a city, then you're going to get much shorter range. But the nice thing is there are cell towers every 2,000 meters or so. And then Lora is also very long range. Again, these long ranges require kind of the clear line of sight. And so unless you're really in a rural area or have a lot of elevation, it's hard to actually achieve that range. Data throughput, Wi-Fi ranges from 50 to 400 and plus megabits per second. We'll see that some of the higher rates in a couple minutes. Bluetooth, actually Classic has a 3 megabit per second data rate, but BLE, which is typically the one shows that the Bluetooth spec chosen for IoT, now has a 2 megabit per second throughput rate. CATM1 and NB1 are much lower. They're about 250 kilobits per second and 25 kilobits per second. And again, that's how you get some of that range is a same power. The higher the data rate, the lower the range, and vice versa. And then the lower part of the way it gets its very long range is it has pretty low data rates as well. But for a lot of IoT applications, this is fine. The cost of these modules are all in kind of the low and moderate. And the good news is when I say moderate, I'm talking about kind of approaching $10 per module. So it's going to be $10 or less for any reasonable volume where we're talking 10, 25, 50K type of volumes. So from that standpoint, all of these are well suited from a cost standpoint to serve IoT applications. And then the other piece is just how do you connect to the internet or to the cloud. I talked about Wi-Fi being kind of IP based, so that's pretty easy. Bluetooth, and this mirrors kind of that security a little bit as well. You need to have either a smartphone, or a gateway. Again, CATM1 is easy, even though the LTE technology is not natively IP based. It does support IP communications. And then Lora also, has that gateway requirement. So the last two, device management and firmware over-the-air upgrades. So these are relatively newer in the last 2 or 3 years, I'd say, as people start to realize if I put 1,000 units out in the field, or 10,000 units out in the field, or 100,000 units out in the field, now it becomes a little bit more important to be able to track my devices a little bit and have the ability to upgrade the firmware. And so all of these technologies support both kind of device management and the photo or the firmware over the air. So that's kind of the good thing about these technologies, why they're popular for IoT, I guess, is it does provide these types of features that make it really well suited. So when you look at this, what you really kind of get down to is kind of your power consumption, your range, and your data throughput. And if you pick those three, to suit your application, then you're pretty good because the others are going to be achievable if not kind of built in. So now let's look at kind of what some of the options are for Wi-Fi. um, Here are the different call them the ABGs of Wi-Fi, and then the Wi-Fi Alliance has come out now and with their Wi-Fi 4, 5, 6, and 7. So Wi-Fi 4 is still extremely popular. 2.4 only BGN devices are still very popular, particularly in IoT applications where there isn't the need to, send video. Now there are IoT applications where you do need to send video, in which case, then you'd have to do something a little bit different. But there's a lot of data throughput available, particularly in the G and N rates. Now A and N operate in the 5 gigahertz band. A only 5 gigahertz and N does either one. If you see a product that's called BGN, you can be pretty sure it's going to be 2.4 only. ABGN, N will have both the dual band technology. So the N is kind of the latest in the 2.4. It does support MIMO, which is multiple in, multiple out. And then data rates up to 150 megabits per second in the 5 gigahertz band. And then a Wi-Fi 5 is AC, and so it only operates in the 5 gigahertz band. But because of the backward compatibility and the best effort characteristics of Wi-Fi, any AC device will also support 2.4 because it has to for, like I said, the drop back. If you can't connect at 5 gigahertz, then you have to start dropping back until you can connect. But very high potential throughputs of 867 megabits per second. It has a multi-user MIMO where you can actually send downstream to two different devices and different frequencies at the same time. And then it does support beamforming so that you can, the access point with multiple antennas can actually kind of do the beam steering to increase the throughput and the range. AD was the old WiGig. It operates in the 60 gigahertz band. It was kind of originally intended for kind of the wireless HDMI for homes. The challenge there is 60 gigahertz is so line of sight that it's really been more focused on doing kind of backhaul, outdoor backhaul type of stuff where you can get from tower to tower. AF was going to be the white space where the analog TV channels were moved, but because it depends on the location where you are, it's been a little bit difficult to implement. AH is kind of the Wi-Fi in the 900 megahertz band. Hasn't gotten a lot of traction, although there are some companies that are out there they're doing it. And then AX or Wi-Fi 6 is what has this has been going in access points probably for the last year. It has really high throughput speeds capable, and the 6E will pick up the 6 gigahertz band. It does operate in both 2.4 and 5 gigahertz simultaneously, so it will do the kind of the dual band simultaneous operation. Again, has beamforming, the multi-user MIMO. Now, if we look at these technologies, like say BGNN is very popular. AC is, what if you bought a computer 2 or 3 years ago, that's what you have in that. The new smartphones that are coming out, they do have the 11 AX or the Wi-Fi 6. But for the most part today, the Wi-Fi 6, and Murata does have some Wi-Fi 6 modules. The software support has to come from the RFIC vendor, so the Qualcomms and Infineons and NXPs of the world. And right now they're kind of limiting that support to, very, very high volume customers. So, maybe in a year, it's going to be maybe more appropriate or more readily available for lower volume type applications. So just give you a sample of some of the Wi-Fi and Bluetooth modules, and you'll see the 1FX does not have Bluetooth, and really it's about the only one we have that if it doesn't have either Bluetooth or an embedded MCU. So most of the new modules, the RFICs that are coming out, they're all coming with Bluetooth radio built in. It's a very, relative to the Wi-Fi, it's a very simple radio to implement. It doesn't really add much in the way of cost, and it's a pretty popular feature to have because a lot of people will use a smartphone with Bluetooth to do the configuration for the Wi-Fi piece of it. I do want to take a minute here because you'll see this throughout. Is you'll see some of the names are in green and some are in blue. And so we kind of call those low volume, high volume. And the reason they're high volume, the ones that are high volume, the reason they're high volume is because of the amount of development work, both from a kind of a software standpoint as well as from regulatory certification. Even though you can see the Type 1XA is certified, it is 2 antennas. So if you don't use the antenna that was certified with it, then you can be looking at a fairly expensive regulatory test bill. So we don't want to have people start down that road and find out they have a lot of development fees and test fees that their volume doesn't really justify. But we do have, that doesn't mean you can't get high performance, good quality products. The 1DX, the 1MW, the 1MW being 11AC, great throughput, multi-100 megabit throughput, very small size, very reasonable cost. The 1LV, low power. The new is this 1XA, which is off the new Infineon 54591 chipset. It is higher performance. It does have the what they call the RSDB, the real-time simultaneous dual band, operation. So it's a PCIe interface. It's one thing to consider. So from Infineon, there's a wide array of offerings to really kind of fit any need that you have. Now you'll see that these modules are kind of gray or silver in color. That's because that's a silver shield over the module. So there's no further shielding required when you use these modules. So again, keeps size down and simplifies the implementation. And you can see that we do have certifications for all of these modules. You'll also notice that none of them have antennas on the module, which means it's going to be typically a PCB trace antenna or some type of a patch at the end of a little RF cable. We also have modules from Qualcomm as well as NXP. You can see that the Qualcomm modules are all in the high volume category, primarily just due to Qualcomm's approach toward support for the software piece of it. But they make very good products. That QCA 9377 in the 1BJ is a very popular part as well. And then NXP in the last, last year, year and a half ago maybe, they bought the wireless portfolio from Marvell. So these that are labeled NXP would have been labeled Marvell. If you're familiar with Marvell, that 88W type of part number prefix ought to be pretty familiar. So with the 1ZM, which is new, you do get the 11AC, the Bluetooth 5.1, and we'll talk a little bit more about what those different numbers mean in a slide later on. This is a new product, and also the Type 1YM, which is a MIMO version with the 11AC. And one of the nice features about both of these is with the Wi-Fi interface, you have both PCIe, SDIO, and USB interfaces. And the SDIO and the USB can also be used for the Bluetooth portion in addition to the UART interface. So if nothing else, there's a wide variety of Wi-Fi modules that can suit your need. And then the others we have are the ones I talked about that have an embedded MCU. These are nice because for simple wireless sensor type applications, this can be the entire intelligence in the device. All right, so you run your application and the Wi-Fi and TCP/IP and Bluetooth, in the case of the 1LD stack, on this module. So all you're adding is sensors and a power source. The new ones we have here is the ABR, which uses the new NXP 88MW320. It used to be the 300, but they've upgraded it to the 320 part. and then the 1PS, which takes kind of the 43907 part from Cypress, adds 11 AC to it, but does have the built-in processor. So again, you can get them with embedded MCUs without giving up the Wi-Fi performance. So now let's take a look at the cellular and the Lora, or what we call kind of the low power wide area technologies. I show the Cat 1. We don't do any Cat 1 modules, but that's what a lot of IoT applications have used previously. So I want to kind of include that so you can compare it with the Cat 1 and the NB1 as well as Lora. When we talk about NB1, that's what's currently out there. NB2 is starting to be deployed, but it's not really widely available yet. We do have a module that supports that, and the advantage of that is it has higher throughput speeds than the NB1, as well as a little better handoff for mobile applications. But the main thing about Cat M1 and NB1 are they have these low power modes where they don't have to check in with the cell tower as frequently as, say, your smartphone does. So you can go several hours, and actually the cellular network tells you how often you have to check in. So you can go several hours to, I mean, in theory, the spec supports a number of days, and during that time, the cellular network will remember who you are and kind of your credentials. You won't have an active slot, but it will remember you. So when you do want to wake up and transmit, you don't have to do that reassociation. And so this drives down current consumptions into the microamp range when you're not transmitting. You can see that the Cat M1, the upload speeds is up to a megabit per second. Your throughput's going to be probably more in the 250 kilobits per second, and then the download is 384. Compare that to the 10 megabit and 5 megabit of Cat M1, and you can kind of see also where some of the power savings can be achieved. But primarily, it's that not needing to check in very often. The upload transmit power, these for all the cellulars, very, very high at 23 dBm or 200 milliwatts. These really are requirements of the cell networks. They want to make sure you have enough power to have good coverage, good experience. They don't want people saying, "Yeah, I've got connectivity issues with carrier A or B or whatever." There's not really voice support, although there is VoLTE, which is voice over LTE for Cat M1, really only designed for kind of push to talk voice capability, and not a lot of it. So it's not really, the carriers aren't really looking to support conversations over this technology, but Cat M1 does have it. NB1 does not, and Lora does not as well. The mobility support, and when we talk about mobility here, is really kind of in the LTE or cellular definition of, being in a car, driving down the road, moving from cell tower to cell tower to cell tower. So the Cat M1 inherits kind of that LTE technology. The NB1 does not. So you're just going to basically disconnect and then reconnect. So for a lot of applications, it doesn't matter. But certainly for non-mobile applications, NB1 can be a pretty strong solution. And similarly with Lora, if it's going to leave the range of one access point, then it's going to have to reconnect with another. The antennas, all of these are single antenna, which reduces costs and space, except for the Cat M1. The resource box is kind of a cellular spec about how many, it kind of affects how much speed you can get, because you can concatenate these resource blocks to get more effective throughput. And then latency. I mean, it's interesting, I guess, a little bit, but a lot of IoT applications aren't particularly latency critical. So even if you had 5 seconds for Lora, that can often be enough. And then the receive sensitivity numbers, you can see why Lora has the best, because it does have the best receive sensitivity. All of these, if you add the transmit power to the receive sensitivity, in theory, in free space would go for, tens of thousands of kilometers, or but in real life you're not going to get anywhere near that. And then a modulation scheme, just kind of interesting from the standpoint of one way to get higher throughput is with these higher order modulation schemes. And you can see that Lora has this interesting kind of chirp spread spectrum that helps it in terms of range, with the trade-off being the kind of the throughput. So looking at what the offerings are for the cellular, we've got these combo modules that will do either Cat 1 or NB, and they can do it, they can switch dynamically, so you don't have to totally reset the device, and it's not a compile time or power up time. We've got what we call our 1SC or our 1SC-DM. Hardware-wise, there's the same. It really had to do with the regulatory certifications. That the DM does dual mode, so it will do both. And both of those can have an AT command set interface, or they do have an embedded application processor on them, where you can run your application in that MCU. So we call it Open MCU. But again, that's only supported for basically 50 or 100,000 unit volumes to get that capability. You can get the AT command in the 1S Edward, 1SE, for any type of volume. So the 1S Edward takes the 1SC, puts it on this daughter card, adds an eSIM to it, adds some additional flash, and adds a second application processor. So it has a separate discrete STM32L462 and the eSIM, and the antenna connector. So it's much simpler to implement this. And the ST Cube has an SDK version that supports the Altair 1250 part. So you get support through the ST network on that. And then for NB only, so why would you do NB only? Well, NB is a simpler radio to implement. So these modules aren't as expensive. The RFICs aren't as expensive. We have one for the NB1 and then the 1YS. That release 14 is NB2. These also include the Open MCU, if you will, but again, these are higher volume requirements in the kind of 50 to 100K requirement at this point in time. And again, these are well suited for stationary applications. So you can think of a meter, or maybe a generator in your backyard or something like that can be a good solution for these. So the other half of cellular is, okay, so what carriers do you support? And so this is kind of the certification plan. And so you can see, if nothing else, that there are a whole lot of carriers that have to be kind of addressed. And they don't all do both Cat M1 and NB-IoT. It shows in the US AT&T and Verizon as just Cat M1, but they're both adding NB-IoT. The other piece of it is SIMs. So how do you do the SIM? We talked a little bit about eSIMs, but Murata's worked with G&D and ARM and for SIMs, and then TruePhone is an MVNO that is suitable for both the 1SC and the 1SE to simplify that carrier connectivity and roaming issue. So the 1SC, you can see today we've got AT&T, SoftBank, KDDI, Korean Telecom, South Korean Telecom, Deutsche Telekom, and Vodafone. And then we're nearing completion with Verizon, Telefonica, Telstra, and then we're planning on supporting T-Mobile. So keep in mind, these are all pretty much MNOs. So there are the MVNOs that work with these guys and provide roaming coverage across multiple carriers. So that's always, right now it's particularly valuable to give you support for in specific coverage areas where maybe the carrier certification hasn't been complete yet. And then for the NB1, T-Mobile is completed, SoftBank, Deutsche Telekom, and Vodafone, and then Telefonica is in process. So you notice I put a date on this because we're continuing to work with these carriers, and more get added over time. So if there's one that's of interest, then just check back and let us know. So now taking a closer look at the Lora modules, we've got three basic offerings. We've got the ABZ, which is based on the Semtech SX1276. Semtech kind of developed the Lora technology, or acquired it, I guess. And the ABZ works in the 860 to 930 megahertz range. It also has a application processor on it, so you can run your application plus the Lora WAN stack on the module and have this be the entire intelligence of your device, just adding in sensors. And there's the AT command software as well, if you prefer. Then we have the 1NM that does the kind of the Chinese frequencies of 430 to 470 megahertz. It comes with an AT command set, but it is a high volume module requirement for the 1NM. And then the kind of the next generation of the ABZ we call the 1SJ. It's new. It's built on the Semtech SX1262, which is kind of their next generation LoRa part. It's otherwise it's very similar. It's a little bit smaller. It's a resin-filled module as opposed to a PCB with a metal shield as the ABZ is. And it has a little bit better performance than the ABZ, and we'll take a look at some of that as we go forward. And it has the AT command set, and so the this 1SJ296 is open for any volume application. So this just gives you an idea of what the different frequencies are, the sub-gigahertz frequencies. So the ABZ and the 1SJ are suitable for all the countries with the green circles around it. And then the 1NM is really for the China. And then the thing about Europe is it supports the 868, but not the 169, which is the other frequency. And then you can see in the bottom right some of the other countries that are supported with the LoRa as well. So there are two different, we talked about kind of the open MCU and then the AT command set. And with the ABZ, there's several different flavors of modem code, if you will. But if you want to do your open command set, you can see on the left-hand side, you just have the module, and then you've got a sensor and a battery. There are two flavors, one that has a hardware encryption engine in the ST processor, and one that doesn't. All right. So these do not require a host MCU that we talked about earlier. Can be the entire intelligence. And then we've got three kind of flavors of programmed modem code. So we've got the 093, which is the Murata modem firmware, which is the AT command set. So it gives you AT command set control. And so for this, you would have to have a host, MCU to run the application code. So you add that. Why would you do that? Well, it's easier to write AT command software than it is to port your code to the OpenMCU version. And you may already have a AT command protocol set up, so you may want to leverage what you already have done. We have one that a code load for machine queue, which ties into their network. Machine queue kind of is part of Comcast, so they kind of implemented the gateway portion of the Comcast public coverage. And they also do it on an as-needed basis now for wherever you need to be or go. And then we have one that ties into the Semtech device management portal. So again, we talked about device management and some of the over-the-air upgrades. This is one where you don't have to do any of that type of code development yourself. It's there, and you just operate with the host MCU. And then with the 1SJ, there is an open MCU version, but it really requires 100K volume in order to get support for that SDK. So depending on what your application is, but again, it is kind of the one and only one. The other flavor with the AT command is where you have the host MCU. The 296 uses the US frequencies. So it's again, if you want to add LoRa to something you're already doing, it's an easy way to do that with just the AT command set. So then here's a comparison between the 1SJ and the ABZ. So the 1SJ is kind of a typical second generation part. It's a little bit smaller, has a little bit better performance, characteristics. But that OpenMCU is a little bit more restricted than the ABZ. So the differences are highlighted on the TX and receive in the 925, 928 band. You've got a couple of extra. Okay. I understand that I have been lost.
And we can hear you.
Okay, all right. I get somebody lost. All right, sorry about that.
No worries.
Okay, so you can see you get a couple of dB extra TX power, and you pick up an extra dB of receive sensitivity. So you say, hey, 3 dB, that's great. That's 70% range. Not really, not at the end of range. So to me, that's certainly an improvement, but it wouldn't be one. I wouldn't decide which module to use based just on those parameters because that difference isn't really enough. The other thing to notice is the current consumption mode in receive. So when you're receiving your 15.5 versus 21, but then probably more important is the sleep mode current, where it's 1.3 versus 1.65. So again, that's an improvement. But all in all, it's not, to me, it's not that critical to one over the other in terms of just pure specs. More so, probably the ability to use OpenMCU versus non-OpenMCU would be my key to determine. And then Bluetooth, we don't do a lot, quite honestly, in Bluetooth these days. Bluetooth is relatively straightforward to implement, but we do have a very small module based on the Nordic 52832 part, which is BLE only. You'll notice that module is two-tone, and that's because that module does have the antenna on it. So where the silver is a shield, and where the dark gray, that's where the antenna is. So in a 7x7 4, you get the entire module and antenna. So that's where we have people coming to us, is to get that small size. And then for higher volume applications that need both Bluetooth and Bluetooth Low Energy, we do have the 1WA based on that Cypress 20721 chipset. It has some really outstanding audio quality features for that. One thing I want to talk about with Bluetooth 5, and maybe most of y'all know this, but 5 came out and it said, hey, twice a data, 4 times the range, 8 times a data, twice the data rate. Well, you don't get all of those at the same time. So if you have twice the data rate, then you get 70% of the range. If you have 4 times the range, you get 1/8 of the data rate. So just kind of keep those in mind, that they're a little bit mutually exclusive. The other thing is that you can qualify, the Bluetooth SIG will qualify devices 5.0 that has none of these features. So when you see something spec'd as 5.0, make sure you understand which of these features you need and which ones are actually supported. And the same thing with 5.1. 5.1 is the angle of arrival, angle of departure to help with real-time location. That's also can be optional. Now 5.2, the big thing about 5.2 is the BLE audio, which will be kind of a isochronous audio for both channels, or synchronous, so that you don't have to, you can send 2 different streams to each earbud and get stereo that way, rather than trying to send it to both and have one relay it and back and forth. We'll see how many of those come out as being optional. So the Bluetooth only parts that are coming out, when they say 5.1, they'll typically do it. Some of the other older parts that have been out there, there's software changes that can be done and enhanced to get you that qualification at the higher spec. So just be aware of that. Okay, so that's a lot of information, but this will be recorded. You can go and look at it, and obviously the Murata website has this information as well. So now let's look at what do you do to evaluate it. So for the Wicked, which is a Cypress development environment and free RTOS, we've got a variety of different boards. One is from Cypress. It actually uses the Murata module on it. Then we have our others, and then the Cypress Pioneer board for their 1LV module, 1LV part that uses our 1LV module on it. So you have the ability to connect these to computers, start working. These boards provide Arduino expansion headers, so you're able to add sensors and things of that nature. So you don't have to be sitting there with 5 different eval boards all jumpered and ribbon cabled together. It's much more easy to create your kind of proof of concept in a way that you're not going to be fighting intermittent wiring issues. I think that's probably the key portion, key point on this. And these are all very reasonably priced that you can get from from Arrow. And then for the low power wide area and the BLE stuff, so we've got different eval kits for the Lora, for the ABZ, and the 1SJ. You'll see the ABZ is actually an ST Discovery kit. So that has been in the channel for quite a while. Very low cost kit that comes with, that gives you access to the ST Cube. For the CAD-M1 NB, these are the 1SC is a Murata eval board. The 1S Edward, which is the more broad market, is another ST discovery kit. So you can kind of see the ST up there, but you also can see here's the module, and then here's the RF cable going to a connector, so you can connect just a standard, kind of rubber ducky type of antenna. And then for the NB, we have similar EVKs as the CAD M1. Again, the ability to put in, just a standard plastic SIM. Both of them have that SIM card connector. Use either, SMA connector for antenna or a PCB trace antenna on the module itself. And then lastly, we've got the BLe EVK that's also been out in the channel for a while, that has a button cell battery holder, built into it. So again, a lot of easy to expand, versatile development kits to help you evaluate and start actually working on your design. When we cut to support for Linux, Murata has focused most of our efforts on the NXP i.MX platform. And so we've worked with a company called EmbeddedArtist, who has created a number of M.2 cards based on our modules. And you can see the images here. So this has become kind of our default evaluation board for these modules. And the reason being is, you plug in this card into that connector, you've got a good solid connection. You don't have to worry about, again, the intermittent connection issues. And when you're running a Linux machine, rather than running an MCU, you're now running an MPU, an A7 class device. Running the SDIO, you're going to be running at higher potential speeds than you might with an MCU. So it becomes a little more important in that regard to have a good solid connection. And you'll see these above the perforation. These are the reference PCB trace antennas. So the 1DX is 2.4 only. This is actually a dual band PCB trace antenna. This is another dual band, as is this. So you can see there's a lot of variety of what you can do with the PCB trace antenna, and get actually really pretty good performance, gains of 0 to 1, 1 dBi type of stuff. And if you don't want to use that, you can see they're perforated, so you can actually snap it off and then connect to the antenna connector on these modules. The 1XA and the 1YM, those are the MIMO parts, so we don't, you can't put two antennas that close together and have them do any good. So we just bring out the RF connectors. The 1XA has a dedicated Bluetooth option, so you can have a third antenna if you want it to. So what do you do to plug it into the existing boards that you have? So if you don't have the M.2 card on your processor EVK, then we have this adapter. And the adapter allows you to plug the M.2 card into it. Then it will plug into a micro SD connector, and then we'll give you a micro SD to SD adapter as well. Some of the boards require some additional cabling to hook up the Bluetooth piece of it. But since that's low data rate, that's not really an issue. So what does it look like? All right, so here it is with the board plugged into the adapter going into the SD card slot. So most of these MPU or Linux-based or Android-based development platforms are going to have an SD card interface. A lot of times that's how you'll boot your initial code. Once you get that programmed into Flash, then that can become available to use. And some of them actually have multiple SD card interfaces. So again, a way to very simply get a very solid connection. And with this M.2 card scheme, you can change modules. If you want to compare two different modules, you plug one in, select the correct driver, plug a different one in, select that driver, and you can compare very easily multiple modules to see which one is best for you. So this shows for the other EVKs, the IMX EVKs, including the IMX RT, as well as you can see over here the 6 and the 8. So again, very similar approaches with the interface. Again, making it really easy to mix and match processors with cards. Then we have what we call kind of our fully modular system. So this is a product that a series of products really that EmbeddedArtist makes. That this particular one is their RT carrier board, and so up here you have a place where you can select a processor board. Here's your M.2 connector, and so you can see that there's the larger carrier board that supports all the 6, 7, and 8 i.MX platforms as well. So here it's just kind of showing here's a what they EmbeddedArtist calls a COM board that can plug in to the processor slot. Then you select whichever module is right for you, and again you can swap swap them out and insert the module in directly into the carrier board, and you are you're pretty much good to go there. All right, so now let's talk about some of the support. So just in general, the Murata support for our wireless modules starts at helping you select what's the right one and why. We can do schematics and layout reviews to make sure that we've got a lot of excellent documentation, but sometimes it helps just to have another pair of eyes take a look at it before you commit to that printed circuit board. The antenna guidance, the application support, any issues you have bringing the module up. Really, all of Murata's modules are 100% tested at the factory, so it's really not been an issue of trying to get modules to come up. They work very well. The certification that we have, so like I say, we certify with a specific antenna. If you want to change the antenna, we support you through that process by helping you get your own FCC ID without doing any testing, and then getting a permissive change is needed. And then we support you through what you need to do in terms of production. And again, all our modules are tested, all the RF output is tested, so that's not really a big requirement. But beyond that, so we talked about the Linux and the Android hardware. So what do we do software-wise? So again, it's focused around the i.MX 6, 7, 8, and RT platforms. A number of the NXP board support packages have support built into it for our modules, and as well as the MCU Expresso SDK. And you can see the various Linux kernels that we have supported, as well as backport support. And then there's NXP and Infineon provide Android support for certain products. So that's one, if you're interested in Android, we just need to check with Arrow or Murata, and we can find out if they've got support for that, or maybe when they're going to have the support. And again, these names down here are what we saw on the M.2 cards. So again, we continue that through with software. So when it comes to Linux, we've got our landing page, we've got quick start guides, we've got Linux users manuals, we've got hardware manuals. We actually have a RF test manual to step you through the RF testing that needs to be done if you're doing antenna testing. EmbeddedArtist has similar type of documentation, particularly around their M.2 cards and these i.MX developer kits. A lot of good information there. Detailed information on the M.2 card family that they have, as well as a host of related resources. So again, you have a lot of documentation support. Murata has a GitHub site for our driver support. So we have the latest of the Infineon-based modules. NXP is coming soon. We'll have that support as well. There's a place to go check to get the latest fixes. And then I think also nice is we're not allowed to provide images for our modules due to software licensings, but we do create on our GitHub site a lot of scripts so that you can just copy this script, run the script, and then build your own image. So again, getting you to market quickly. And then EmbeddedArtist also has their GitHub site, and again they have images with the Cypress or the Infineon FMAC driver kind of built into that. And they'll be adding NXP as well. In terms of the free RTOS, we have similar levels of documentation, quick start guides, hardware reference manuals, test reference schematics, the test manuals. EmbeddedArtist has some stuff dedicated to the 1052 and 1062 RT as well as getting started with their different products. So they have a very nice modular scheme that helps. And then for the free RTOS, Cypress or Infineon, and you'll see I use those interchangeably because they're changing their branding now. But they've got the Murata Toolbox, which is focused on support for modules with their PSOC family, their PSOC 6 in particular. So again, this allows you to create your own application program and compile in the necessary libraries. The Wicked Studio, which is kind of the precursor to the Murata Toolbox, really focus more on the STM family of processors, but again, the development environment for you there as well. And then with NXP, their MTU Expresso for the i.MX RT, as well as for their the 88MW 320 as well. So again, a lot of different levels of support. And then finally, the community forums. Murata launched ours last year. We've got it for i.MX. We've got it for free RTOS. We've got it for all the modules. You can request software through there. You can look and see if somebody's already had your problem or your question already answered. Infineon has theirs for Linux and Android, as well as Wicked and Modus. And then NXP has one as well. So again, you're not stuck with just one company. You've got this partnership of companies along with Murata and Arrow to help get you to market quickly. So just to kind of summarize what we've said, a lot of different wireless technologies will work for IoT applications. Kind of the challenge is figuring out which one is best for you. There are a wide variety of different offerings. And all of these standards are really well regarded. These are mature standards that have been out there for a while, so they've kind of stood the test of time of security and implementation. And then, kind of the last sales pitch is Murata and Arrow. They've got everything you need to get it going: products, evaluation solutions, hardware support, software support. The EmbeddedArtist products are available through Arrow as well. So, please turn to us for your next wireless IoT design, because I think we can get you, what you need quickly and get your product into market as quickly as possible. So with that, I've just lost my screen, but we can open it up for any questions.
Thanks, Tim. Great presentation.
There we go.
Thank you. There are a lot of questions in the chat box, and I know that Paul Peterson with Air Electronics has been great answering most of them. So I'm trying to weed through and see which ones he may not have gotten to. One here that I see may not have gotten a clear answer. Do you have anything available that includes LoRa and GPS?
No, we don't. The the LTE Cellular CAT-M1 product includes GPS, but we do not have LoRa and GPS in a single module.
Thank you so much.
Someone had added a comment in there, Tim, that and there is, if you take a look at the Semtech type of on their data sheets, there is a mention of a location engine that they're putting in their latest silicon, and the Murata module is based on that latest silicon, but it's not GPS. This is not a satellite type function. It is a way to do location based off of known fixed points. I would say it's still in development at best. It is interesting though.
Yeah.
Because
I mean, there are a lot of different location schemes, right? So you can use the receive signal strength and try and triangulate off that. If you've got multiple access points, you have time difference of arrival. We talked about Bluetooth, the angle of arrival, and you can do that with cellular as well. So it's an area of interest. Murata really kind of follows the technology roadmaps of the RFIC vendors. So as they add those features in, then they will be in the Murata modules.
Yeah.
Thanks, y'all. Next question here. Are you doing carrier certification?
So I glossed over that a little bit too quickly. So yes, we do carrier certifications for our modules, but there is still a requirement from the carriers that the end device also be certified, right? But where previously, that used to be a long, involved $50,000 test. Now, and what you really do is you take your device with our module in it, you connect your antenna to it, and then you actually go to the field basically, and for most of them there are specific areas you go, and you run a series of tests that they kind of tell you what to do. They kind of measure the results of what you've done, and then they'll say yes, okay, you're good, or hey, here's an issue that you need to address. For the most part, it's going to be, hey, is your antenna implementation good enough? Because the one thing they don't want to have is a bunch of devices that have marginal connectivity that sit there and keep trying and trying and trying and trying. So, it's a much lower effort and cost in device testing, but there is a requirement to do that. But because we have the module certification, all the hard stuff about the LTE interactions and things of that nature is already taken care of.
Awesome, thank you. I think all of the other questions were answered in the chat box. If I, for some reason, missed yours, please feel free to unmute yourself and ask. I did want to save, I know we have 5 minutes left, a couple minutes. I know Ed Bray just wanted to quickly introduce himself, and I think maybe Mike Honkop and Paul Peterson, if you want to do that as well. We do have a couple minutes. So I wanted to give those guys that opportunity to do that.
Sure. Thank you, Carolyn. Of course, she said Ed Bray. With AEM Group, we're the manufacturer's representative for the Southeast, supporting Murata Electronics and collaborating with Aero Electronics, of course. I noticed some questions about batteries and wanted to mention that we do have a technical show, a podcast evolving of sorts that you can access on our website, and I'll put this out on the let's see, I had it there. There we go. That information out there. They're short episodes. We do have a battery power storage series that has been posted. Episodes 1 is battery basics, basically answering the question, if you have a design requiring battery power, what are some of the things that you need to consider? Episode 2 is lithium chemistries. We do have an episode 3 on the way, custom battery packs and charging systems. And then other series also, the next series, actually Tim was nice enough to contribute and to the content for the wireless communication series, episode 1 on wireless basics, and as well as HMI series, circuit protection series, and on. And if there are other subjects you would like to hear us talk about, then definitely let us know. You can subscribe on the contact tab on our website at aemgrp.com. We thank you very much.
Thanks, Ed. Mike, Paul, if you want to hop on and say anything, you're more than welcome to. Again, I just wanted to thank Tim for a wonderful presentation. Thank you to Mike and Paul with Aero Electronics for setting this up. They are great partners of Riot's. I encourage you to check them out, add them on LinkedIn. They're great resources to the community. If no one has any other questions, I would just like to, again, thank you all for attending. Again, this presentation was recorded and can be found on Riot's YouTube channel and our meetup pages. I hope you all have a great afternoon and stay safe. Thanks, everybody.
Thank you.
Thanks, Caroline.
Thanks, everyone. Appreciate your time today.
All right. You guys have a great day, and we appreciate your time.
Thank you.